So we're recording. There we go. Okay, so we're going through the basic fire pump. Last time we went through a lot of the kind of the boilerplate stuff about water and everything like that, and some of the fluid dynamics. Today we're actually going to talk about the pump. I am going to tell you that to make the class closer to an hour, which is what one of the things the deputy Lemoria wanted us to be able to do, is I adjusted some of the slides for day training purposes. When we post this up, the whole presentation is going to be on. So for anybody going through for their state certification, you have to go through all those slides. There's a few things about piston pumps that we don't have in Scarborough and things like that that I took out that you may see questions on if you're going for your state certification. So you make sure you go through all those slides. So obviously you get the objectives page here. We're just going to kind of blow through that. We're going to explain the importance of the pumps, describe the interior, all that stuff, boilerplate. One of the essential duties of fireground operations is water supply. And that all comes down many, many, many times to the pump operators. Whether you're pumping the attack line, the attack pumper, or you're pumping the water supply truck, you can't put out fire if you don't get water to the scene, and if you can't get it to the crews. It becomes a safety issue. It becomes a logistics issue. Knowing how to run a fire pump on scene is one of the key factors in good fireground operations. We're going to go through a lot of the basic things of each pump. So each fire apparatus has a water tank, and everything that's in Scarborough has a water tank, to include both ladders. Okay, the only one I believe they can be made out of metal, they can be out of poly, but everything still has a water tank. If you look at the picture on the right, what you're looking at is the interior of one of the tanks. It's whether it's metal or whether it's poly, like the one you see on the left. Those things going back and forth, those are called baffles. And remember, if you remember from last meeting, we talked about water having weight, mass, velocity, things like that. If you do not have a full tank of water, or even if you have a full tank of water, you're driving down the road, the baffles help slow and control the movement of water inside that tank. These become very important if you're driving tanker apparatus that have more than 1,000 gallons of water on them. They break them into quadrants like this, so that as you're turning left, right, stopping, accelerating, it slows down the water. There's holes cut into the baffles at the bottom and at the top, so that your water is able to move slowly through the tank. It just helps you. If you didn't have this, if you tried stepping on the brake without any baffles, you'd feel a huge surge coming to the front of the truck. So again, this is where I took out some of the slides. They went through a lot of things about different styles of pump drives. All the trucks that we have in Scarborough are either one of two types. They're the midship transfer case. You could spend a lot of time talking about this. Does this really matter about when you're pumping? It does in one sense. When you guys drive, or folks drive up to a scene and you're putting a truck in gear, you need to allow the motor to idle down. You need to stop forward momentum, and you need to be able to let that transfer case shift from the road mode to the pump mode. If you look on the right-hand side and you look at the top picture, the motor is to your left, the pump is in the middle. Down at the bottom, you'll see there's a short drive shaft that comes out of the back of the motor to the pump. Then there's a drive shaft that goes back to the wheels. The transfer case is down in the bottom here. And what that does is it allows when you go in the truck from road mode to pump, it disengages that rear section of drive shaft and puts the power into the pump. So that is why, if there's any tension on this, where you've put where you set the brakes, that's why you run into problems with grinding gears, or a pump not fully engaging, and why we run into a lot of the problems that we've had with engine 6, engine 5, and engine 3. There's not a lot of space in there, and if they don't fully engage, you end up ruining a lot of the gears in there. So that's why it's good to be able, when you come up to a scene, stop, set your brake, move the pump lever from road mode to that middle neutral position. Okay, obviously your transmission is in neutral as well, but move that pump lever down to the middle section, and then count to like 1, 2, 3, and then drop it down into the bottom, and then hit drive, because that is what allows us enough time for that pump to disengage the rear wheels and move it to the pump mode. The other type of truck we have is the 2 tank trucks, and we also have a skid unit over there. Basically, an engine-driven pump is the pump is hooked directly to the motor, so as soon as you start the motor up in the back of that, the pump is turning. There's no clutch assembly, and there's no shift mode to be able to put those in and out of gear. The modern fire pump, again, this is where I took out some of the slides. So again, you guys, people going for the state certification, make sure you pay attention to this, go back and read through this. We took out some things here. The modern fire pump is a centrifugal pump. It works off a spinning motion. It brings water in. This is where you guys really need to start paying attention so that you understand the theory of how a pump works. You don't need to really understand how to fix it, but as far as mechanically when things go wrong, but you need to understand the pump theory, because when things go wrong on the fire ground and you can't get water, a lot of times you need to be able to understand the pump theory so that you can overcome and adapt to any issues that have come up. It works off a spinning principle. It takes the water into the center. Now, if you look at the diagram, we need to talk about some common vocabulary, so we're all in the same thing. The shaft goes down the middle. The eye of the pump is where it is. It's in the center of the pump. If you look on a fire truck, there's 2 steamer ports off either side, lead directly to the eyes of these pump. If you break off all the stuff, eventually you'll get down to the basic pump itself. Those 2 will go directly into this eye. This impeller is not a propeller, it's an impeller, and it's inside of the pump, spins and throws the water out these veins, okay? And it works together with the casing to make the build pressure to move water through the pump. That's what a fire pump looks like out of a truck. It's just a big metal casting. The pump is down at the bottom where you can see the spinning thing, where you'd see the impeller. And these are the 2 directs right in. These are the 2 eyes. These are the steamer connections on either side of the truck. This is how it would set in the truck if you were looking either at the nose or you're looking at the tail. This gives you just a little bit more of a broken down diagram of how a pump works. You have the eyes, you have the impeller. Now what it does is that impeller spins in a little area called the volute that throws the water, goes into the eye, goes out the veins, goes into the volute, and as it spins around, if you look right on the corner, you'll see what it calls a stripping edge. And that's what it cuts water off and sends it directly up through the hub and up into a discharge. And from there, it goes into a manifold and out through the rest of your fire truck. The reason that you need to know this is that if one of the things is cavitation is a big problem with trucks, with operators sometimes. If you get if you're trying to pump more water than is coming in, you're going to get cavitation. This is where the bubbles start forming. They're not bubbles of air. Well, they could be bubbles of air, but they could also just be empty space. Hopefully, if you're trying to pull too much water out, what happens is those bubbles go around this, causing disturbance. They hit right on the edge of that stripping edge. That's what causes that sound of marbles going through your pump. That's where it all happens, is right in here. And over time, you keep doing bad things to this, pumping dirty water, cavitation. This is where all the wearing occurs inside the pump. We just talked about this. The water goes in the eye. I'm going to break this down real easy. The water goes in the eye. The faster you turn the impeller, the more force you're creating, which increases your pressure, and which pushes the water out through. You can actually, just by the static or flowing pressure of water coming in, water will literally flow right around this, up through and out through your fire apparatus. It's not going to build any pressure, though, until you apply power from the motor. Again, just a lot of words, but basically that breaks down into the basic pump theory is that. The reason I left this slide in is because on your tachometer for your RPMs, you're not going to be getting these numbers. There's a gear ratio inside of the pump that increases the spinning capacity of what you're doing. So you may be at maybe 1500 RPM, and your pump is usually a 1 to 10 is increasing the speed inside. Again, this is why it's important. Multiple pictures shows different things, but again, water in the middle, follow the drop of water around. It's like, and then it goes through here, hits out, comes around, and out the discharge. There's two types of centrifugal pumps. In Scarborough, we have one left that is a 2-stage. Everything else is a single stage. We're going to start with the single stage first, since the primary of what they have. Basically, what that means is you have an impeller. The water can come in from comes in from both sides. You have if you just look at the diagram, basically the water comes in one side and then goes out through. You can see right here, you can see it: discharge manifold, flow pattern, follow the drop of water in, and you can see it. A 2-stage pump works it has 2 impellers in it, okay? So the way this works is that if you're in pressure mode, the suction comes comes in, the water comes in one way of your intake. It goes into one impeller, and again, this is a pressure mode. Water comes in, goes through one impeller, bounces to another impeller, and then goes out, okay? When you're in volume mode, the water is drawing in from both sides of the pump and uses both impellers to push water out. So in the transfer valve is what you see on the side of the truck. It'll say either pressure mode, it'll say volume left, pressure right, pressure series, capacity. Those are the 2 words that you're going to see. They'll either the one on the top is what you're going to see on engine 2, the spare truck. The reason that the transfer valves and you had a 2-stage pump was the older trucks didn't have the horsepower to be able to spin an impeller fast enough to be able to create the pressures and to move a lot of water. So they needed to increase the pressure to overcome this. As fire trucks developed more horsepower and they had bigger motors available with diesels, they were able to do away with the 2-stage pump and go to a single stage and just piping and the size of the impeller, were able to get rid of that second impeller. They were able, and by using more torque and power out of the motor. It simplified the pump, less stuff to wear out, basically. But the big thing is that what you're going to notice with two-stage pump, and we'll just talk about engine 2, is that if you're doing the truck check in the morning, the way you know that this is working is that do your truck check, and then you're going to run the truck at a certain RPM and load and look at what your pressure is. Say it's 1500 RPM and your pressure is 150. To know that the volume side is working, throttle the truck back down, swap it over to the volume mode from pressure, throttle your truck back up to the same RPM, and your pressure is going to be lower because it's not trying to build pressure to pump through small line. It's trying to move as much water through LDH. Here's a key thing to remember, that when you use your volume, when you swap to volume, is when you are pumping over the capacity, half the capacity of the pump. So if the pump is rated for 1,000 GPM, if you're pumping more than 500 gallons a minute, you need to be, whether you're in attack or in supply mode, you need to be in volume, because to get the flow that you need. So again, if you are flowing from your hose lines more than half the capacity of the pump in a two-stage pump, you need to be in volume, okay? Again, just more diagrams on how a transfer valve system works. When you're swapping these transfer valves, you need to idle down each time. You need to pick which mode you're going to be in, because how that works, there is literally a piece of metal in there that swaps the flow of the water. So you don't want that changing on the fly. So if you know that even if they change it on you and you start with an attack mode and you're only pumping 250 gallons a minute, and then as you work your way through the fire, you're pumping more than half the capacity of the pump, slow down, let everyone know, throttle down, change over, and go back up again, because you don't want stuff breaking. So part of our priming, part of the system of a pump is to prime the pump. Again, a lot of words, big slide, but essentially what you're doing, whether you use an oil-based primer, which I believe we've pretty much gotten rid of in Scarborough, like this, or an air primer, what you're doing is you're removing the air that's in the pump system to create a vacuum condition, okay? You're not drawing water into the pump. A lot of people call it making a pull, you're pulling water, you're trying to get water in. What you're doing is you're evacuating air, and the way that works out of the pump. And to do that, you need to have a pump to pump out the air. Water comes into a fire pump under either pressure, or you're bringing it in under draft. That's the two ways you're bringing it in. Priming pumps typically are used when you're going to be under draft situation, unless once in a while you might go out in the morning, or it might happen on a call, and you put your truck in gear and you get up on the pump panel and you open your tank to pump and you try to move water and you can't build any pressure. If your pump is tight, once in a while, when I mean by tight, it means there's no leaks. Once in a while, it can be called a situation where it develops called airbound. A section of air is at the top end of the pump, and it just is locked there and won't let water into the pump. So sometimes, even from a tank to pump situation, you still have to hit your primer. As soon as you hit the primer, you'll see the pressure come up and your pump and the motor will sound right. But priming pumps work. There's a double gear system like this that draws water, uses a Venturi effect using oil. These were the old style that dump oil on the ground. Then they went to oilless ones, and then now they're using air primers. Again, a lot of the activated right on the pump panel. Most of the older style the old style electric primer pumps had a duration cycle of 30 seconds to 45 seconds. The reason is basically all that is a starter motor hooked to a small pump down on the side of the pump, on the main pump. And if you were pressing the button long enough, that would heat up that pump and burn it and heat up the motor and burn it out. So if those older systems, you were trying to draw a draft, if you couldn't pick up a draft in 30 to 45, maybe a minute, you had to stop, let everything cool down, and then find out why you were not getting water at that point. Air primers, they use the air compressor system. Basically, they pump water. They use air instead of oil. It's cleaner. It uses a Venturi system. It's still pumping the air out, using water going by, pulling air, creating a vacuum so the water can enter the pump. So, relief valves. Jim raised his hand. Okay. Go ahead, Chief.
All right, hang on one second. I'm trying to get this right. Can you hear me okay?
I can hear you fine. Yeah, I saw, and you're the first one to try that. You raised your hand, so this is new. This is cool.
For those that want to know how to raise their hands, if you go down there and click on participants on the very bar on the bottom, it'll bring up a thing for it, and it'll say raise your hand, lower your hand if you want to have anything to say. But anyways, I sent through chat while you were talking. There's some really good YouTube videos on our pumps. If you just go to YouTube and search waterless pumps, a lot of good stuff came up. I shared two of them with you. One was the single. It shows the water flow through our single stage pumps. The other one is the one that I shared was on our priming systems. With the exception of engine 2, all of ours are that oilless primer. I'm sorry. We have engine 7, the newest one, engine 7 is the Trident air primer.
Yep.
The one on most of our other trucks are the oilless primer. We have one left, engine 2, which has the has the oil tank with it. That's the only other one we have. But there are some really good videos that you can watch that are animated and shows the operation of the pump. Thanks.
Okay. So,
Lou,
go ahead.
can we click on the links and still keep the Zoom meeting open for the YouTube videos?
What I would suggest is watch the YouTube videos afterwards.
Okay.
Okay, so moving on. Relief valves. There's two types. There's one to protect the water from coming in, and that's the truck itself. That's an intake relief valve. And then there's a discharge relief valve, which is meant to protect the people or the next truck down line on the hose side, okay? And this is, so we go, work? Yep, there we go. Okay, so a discharge relief valve. Again, a lot of words, but basically this is how it works. If you look on the diagram, there's a spring under tension, okay? And water is coming out of the pump and going out of discharge. This could be one of the 2.5s on the side. It could be one of the LDH discharge. Could be one of the pre-connects. When you set your pump to a pressure, and we'll call it 150, whether or not, when you set that relief valve to 150, when you're flowing water, while you're flowing water, you add a second line, you set that one at 150, or you set that one at a different pressure, whatever. When one of those two hose lines shut down because your flow is increased, when one of those two lines shut down, that water that was going out that hose line has to go somewhere. The pressure has to go somewhere. So that's why they built in relief valves. Otherwise, you're going to be jumping the single line that is still operating. You're going to be jumping that line up and down. That's why there's relief valves on the discharge side. These are what the relief valves look like. The one on the right, it was the water rest. The one on the left is what we have. Ladder 1 has this, engine 2 has this. I believe that's the last two of that type. And engine 4 has the water rush on the right-hand side. These are the internal relief valves. So, So the intake pressure relief valves can be either inside the truck or outside. These are what's on the side of the truck. These be called Jaffrey valves. The way they work is that when the water is coming in under pressure, whether it's coming from a hydrant or coming from another truck, they hook up and you set them, and you open them up, and these are set to a certain pressure to dump. Designed they stop water hammer. They make working the whole pumping system much easier. So electronic pressure governors. This is what most of the trucks coming through now. They, instead of using springs and mechanics to make that happen, it's using the engine speed to control the incoming pressure and the outgoing pressure. It has two modes. It has a PSI mode that use when you're using the attack mode part. If it's being used as an attack truck, you want it to be in PSI mode. If you're trying to work on the water supply side of it, as far as anything else but the attack piece, you want it to be in RPM setting so that it's working correctly. Engine coolers. So these, if you look on the side of the truck, there's whether you're on the top pump panel or on the side, however you have it, there's always these extra valves looking around. Engine coolers, basically what this does, it takes some extra water and it starts moving it through around the radiator to create, to help keep the truck cool when it's sitting down. If it's really, really hot out, if it's like a 90-degree day, this is where these are going to be operating, because you have the truck's not going down the road, so air is not flowing over the radiator. Fire trucks usually should have oversized radiators and fans to be able to work in a stationary condition. But sometimes it's still hot enough out that these aren't going to work. So that's why you would open up these valves and basically run the water around the pump. It's called the heat exchanger, and then brings it back and cools it down. Helps keep your truck from overheating. Pump coolers do exactly the same thing. You're gonna flow water around the pump. The reason that you don't ever want to run a pump without enough water in it is a couple of reasons. One is that fire pumps are lubricated down in the bottom part of it by the water that's in it. That's what keeps from the friction building up in the system. Heat from friction. So it needs water to actually work. The other reason that you don't want to run without water in it is obviously cavitation. It goes through a whole series of valves. You have a crank activated valve. You have hand cranks, quarter turns. These are what all the valving looks like. If you took the side of the pump panel off, this is what you'd see inside on top of the pump. Butterfly valves, these are what is known as your MIV valve. These are electric. They also have a mechanical version that's in the next slide. But this is what, if you look on the pump panels overall, there's always one that's an MIV valve. This is the side that's usually that you're taking in pressure from. These are either air or electric, okay? And they operate, the reason they're NFPA required to have a mechanically operated valve. So that's why this is what they look like. These need to be operated all the time when you're getting up and doing your truck checks in the morning. Make sure that you're operating the MIV valve. Open and close it a couple of times, because what happens is that big butterfly that's in the middle, if that just sits there, that gets stuck. And the motor or the air pressure is not enough to kick that open, and you're not going to be able to get water into your pump from that side. So these need to be operated. To tell if it's working or not, you can do, and you don't even have to have your truck in gear to do this. Take the intake cover off that side that has the MIV on it, take it off, open your MIV valve. If a lot of water comes out, it's working. Now close it. The water should slow down, okay? One way or the other. So if no water comes out, you've got a stuck valve, you gotta get that fixed. This is a manual butterfly valve. Same thing as what you see on the back. It's just same thing, just worked by hand. All fire apparatus have drain valves. The reason is to get excess water out of the system when you're done, okay? They're all at low points. And here's the NFPA, here's the standard. One of the things that you got to be able to lift through 20 feet of strainer, suction hose, you got to be able to pump at 100% capacity at 150 PSI, and just read down through there. These are what we go through when we do the annual pump test every year. If you ever question about how many gallons per minute is this pump capable of doing, that's where these come into play. Somewhere on the side of the apparatus, either in the car, in the cab, or right near the pump panel, somewhere in there, usually right on the pump panel, you'll see these placards. And you'll see that the pump will, like this one was rated on the right-hand side, 1,002 gallons at 150 PSI at 2023 RPM, okay? It's a 1,000 gallon a minute pump. That's how you know what your truck is. If you look at the one on the left, you're gonna see it's 150 PSI, single stage, 1504. That's a 1,500 gallon minute pump. So that's how you know. If anyone ever question you, that's where you can find out that information. And that's it. Now I'd like to open up, and I'm sure that we kind of went through that awful fast, maybe a little bit faster than we should, but we'll just open up the questions now. Go ahead. Stop share. Does anybody have any questions? Go ahead and unmute. Nobody has any questions on pumps whatsoever. That's weird. Okay.
Jeff, I have
Go
a
ahead.
question.
Go
Well,
ahead.
I don't have a question. I'm just, this is a lot of information to take in, and I want to go over it again. I sure have a lot of questions. I just don't know how to ask them at this point.
Okay.
So that I have a question, but I do have questions, but not at this moment.
Okay.
Okay, so that's where I am.
Okay, that sounds good. For those who are going through the state class, this is a lot of go through the stuff again. If you have questions, we can do one of two things. You can, if there's a few people that have it, I can deal with them individually. If there's a lot of people that have questions, we can set up a Zoom meeting for just the people who are doing the class, or we can do it, we can actually do an in-person class. If that might be easier, maybe we can set up an in-person class at some night, or afternoon, or however a date that we have questions to deal with that sort of stuff.
Sounds good to me.
Okay.
And thank you.
Oh, not a problem. Okay, so if
you could each just chat your name in a chat section, those of you that are at the table, just group setting, just do a chat with all the names of the people. That'll help us create a roster and training roster for those taking the actual pumps class. If you could do that before you log out, that would be great.
If we're on duty and not in the pumps class, do you want us to do that?
Yes, go ahead and send any names and we'll work on creating a blue roster from one location.
so again, I know that was a lot of information, and it's something, and to throw it everyone over in a slide section. A lot of times working with pumps it's practice. Take what you learned here and go out and practice. Ask questions, ask questions, ask questions. There is no dumb question, especially when it comes to understanding how to do this. There's always weird things that pop up. I've been pumping fire trucks since I've been 14 years old, and you still run into problems whenever, you still run into weird things here and there. We haven't even touched on drafting yet, okay? This was just a basic pump theory, okay? So get out. The biggest thing you should be able to do is when you pull up on a scene, you should be able to get water out of the tank, float around the pump, and pump 2 hand lines, and you should be able to get water into your truck. That is absolutely the basic thing you should be able to do, and you should be able to do that rapidly, okay? That shouldn't take you long. It should become second nature. It should be like putting on an air pack. You shouldn't even have to think about how to do it. And with that, if you try to go through that step and something happens that it doesn't, you need to know how to overcome and fix the problem, because unless the truck is literally broke, there's things that you can do to make sure that usually somewhere that to overcome a problem. So again, if you have any questions about this, let me know. Email. Everybody's got my cell phone, email, text me, whatever, and I will get back to you. If for the people for the class, again, maybe if this is too much information, there's only about a dozen people that are going for the certificate. We can do a classroom session somewhere, or another private Zoom meeting or something. We'll go over it again, but practice. So anybody else have anything?
Lieutenant, I was just going to pipe in for 1 second about.
Go ahead, Dap.
You know, it was a big transition for me when I started working per diem in Scarborough and operating on a regular occurrence. And the real big game changer for me was the electronic pump control systems, which are standard on the trucks now today. And just as an observation I had was, I think most of the issues that I've witnessed was if somebody was having issues with water, with getting water, whether it's from booster tank water or a pressurized system, most of the time it went back to that pump control system is designed around when it senses a low water situation, you can't do anything with it. You can't get any throttle out of it. And that is when most people, when things start to fall apart. And I've always found that was always a good place to start. And if you have a situation where you cannot get any RPMs or any throttle, and you can't get any water discharge, most of the time it goes back to either, as you spoke of, the dry pump condition, where there's no water in the pump, and that can be it needs prime because there's air in the pump, or it was the tank valve wasn't completely open, or in cases when you're using a pressurized system, the MIV was closed. And I just made that as an observation that most of the time when we have issues on the scene, it relates to not the pump control being in a mode where it won't do anything. And what operators really need to do is develop their own process for starting at one point and working to the next. And that's a good practice to have. And most of the time it's check to make sure the pump is in gear. Is the transmission in drive? Then go to, is there air in the pump? Is the valve open? But when you start to have an issue, you have to have a committed to muscle memory, a system to start from one end and work to the other to make sure that you can clear the problem.
Again, this class right here, that's why the slides are one thing to get the information out there. This class, this part of it especially, we all need to get up on the pump panel and actually start moving levers. This is where the hands-on portion is really going to be exceptional. You don't have to be in the state class that we're doing. Every day, go out and look at the truck, look at the pump panel, move levers, ask questions, practice getting water out of the truck. This is not something that can be learned sitting at a desk or watching a PowerPoint. You have to get out there and use the truck and ask questions from people who's around. Ask your officers, ask other operators, maybe, have a group session, and talk about the stuff. But you got to get out there and actually touch the piece of apparatus. So I don't see anybody else raising their hand. Anybody doesn't have any questions? All right. Nope, no one else is good. All right. So with further ado, that is it. We'll meet again next week. If you get any questions, anything like that, any observations, just get a hold of me. And rest of you, have a good day and stay safe. We'll talk to you. Bye.